the appliance is equipped with a defrost heater, such as in a domestic frost-free refrigerator, turn on the defrost heater to help vaporize any trapped liquid refrigerant, and that will help you speed the recovery process. Now, this is actually a test question I've seen. Refrigerators built before 1950, good luck finding one, may have used methylformate, methyl chloride, or sulfur dioxide as its refrigerant, and should not be recovered with your recovery device. Small appliances used in campers or other recreational vehicles may use refrigerants such as ammonia, hydrogen, and water. Therefore, should not be recovered using current recovery equipment. So, your recovery machine, a black and yellow machine, it's made to remove 3 kinds of refrigerants: Class 1, Class 2, and HFC refrigerants. It's not designed to remove any of those things in the first part of the paragraph, nor is it designed to use recreational vehicle. Ammonia, hydrogen, and water are the components necessary for chemical absorption air conditioning or refrigeration. So no, we're not doing that either. So we're only going to use our recovery machines for CFCs, HCFCs, and HFCs. Another one, going back, charging cylinder. There's one in the electric lab, believe it or not. I haven't used one in 30 years, but here we go. When filling a graduated charging cylinder with a regulated refrigerants, Class 1, Class 2, CFC, HCFC, the refrigerant vapor that is vented off the top of the cylinder there must be recovered. Like I say, these things are, they've been gone by the way of the buffalo since the scale came out, weight scale. Type 2, technicians maintaining, servicing, repairing appliances that are considered high pressure or very high pressure that have more than 5 pounds of refrigerant. You have to be a Type 2 tech or hold universal. Examples: split air conditioning systems and heat pumps. Leak detection. After installation of a system, you will pressurize the system with dry nitrogen and leak check. And in order to determine the general area of a leak, use an electronic or ultrasonic leak detector. To pinpoint the exact location of that leak, use soap bubbles. A refrigeration unit using an open compressor that has not been in use in several months is likely to leak from the shaft seal. So if you see railroad cars have electric motor, they have a mechanical coupling to go to a compressor. The compressor is usually 4 pistons, and these are 12-ton units that would hold more than 50 pounds of refrigerant. In the wintertime, they're not going to be running because there's not going to be a call for refrigeration. There's going to be a call for air conditioning. So what you have because you have not a hermetic compressor, you have an open compressor, and the compressor connects to a motor. It has a shaft seal. We have to create a barrier so the refrigerant doesn't escape through that shaft seal. So what we have is we use a carbon ring that constantly is pressed with a spring up against the faceplate of the end bell. Over time, when that compressor is not running, refrigerant will work its way behind that carbon ring and it will leak out. Those shaft seals, those carbon shields, also will wear out if they're being run excessively, and it's a source of a leak. If you have this leak, if you have a shaft seal, if you have an open compressor, then you can most likely consider that you're going to have to do a seal job in order to get these things closed. Now, there was no leak requirement under the law for type 1 appliances, but that's not the case for type 2 and will not be the case for type 3. Here comes the law. The law is the same for type 2 and type 3. So if you learn the law for type 2, it's the same for type 3. There's going to be two parts. The EPA requires that if it's a comfort system, cooling appliance, meaning an air conditioner, that holds more than 50 pounds of refrigerant, it must be repaired when the annual leak rate is more than 15%. That's the first part of the law. So, if you have a system that has less than 50 pounds, the law doesn't apply. If you have a system that has more than 50 pounds, the law will apply. If it's at a house air conditioner system, it can't leak more than 50 pounds a year. So it can't lose more than 7.5 pounds. The next one has to do with commercial. Leak requirements, commercial and an industrial. The EPA requires that if you have a commercial industrial system, more than 50 pounds, the leak rate is a little more forgiving. It goes up to 35%. So for air conditioning, it's 15%. For commercial, it's 35%. In both cases, there has to be more than 50 pounds of refrigerant. Now, this is the definition of commercial and industrial. You know, it's pretty straightforward. Commercial is retail, food, cold storage sections, restaurants, supermarkets. Industrial is more like pharmaceutical, manufacturing. These are, the key here is customized appliances used in the process of making something, which includes ice machines and commercial ice rinks. Like I said, that's true for type 2. The same exact rules are true in type 3. Now, recovery equipment. Recovery equipment has to be certified by EPA using underwriters or someone else to meet the ARI standard. Recovery requirements. Because refrigerants that you are recovering can contain acids, moisture, oil, frequently check and change both the oil and filter on a recycling machine. Recycling and recovery equipment using hermetic compressors have the potential to overheat when drawing a deep vacuum, because a hermetic compressor, as you know, uses the low pressure suction refrigerant to cool the windings of its motor. So before you use a recovery unit, you should also check to make sure the service valve positions, the recovery unit oil level, and evacuate and recover any remaining refrigerant from the unit's receiver. When you're working with multiple refrigerants, this last part is what I want you to really kind of like highlight or pay attention to in your tape. Because this is a test question. When working with multiple refrigerants, before recovering and or recycling a different refrigerant, purge the recover, recycle equipment by recovering as much of the first refrigerant as possible, change the filter, and evacuate. This is the first part of the question. This is the answer right in here. The only exception to the rule is the tech working with R134A, who has to use a special set of hoses, gauges for recovery. Recovering refrigerant in the vapor phase minimize the loss of oil. Recovering as much as possible in the liquid phase makes it go faster. The tech may choose to speed up the recovery process by packing the recovery cylinder in ice and or applying heat to the appliance. After recovering liquid refrigerant, the last step always is to recover as a vapor. in order to get all of the refrigerant out. Always recover, the last step of recovery is to recover as a vapor. Refrigerant should be placed in receiver of units that have a receiver